Hi, everybody. So, good news, we're finally done with factoring. Because we're still online, we are going to talk about some completely brand new stuff. And it sort of relates to at least factors of numbers, but at least we're finally out of the woodwork with the concept of factoring. So that's good. Unfortunately, though, the stuff that we're going to talk about over the next few days, I don't think there are any separate sections for it in this textbook. If you do Google the topic, which I'm going to show you in a couple minutes, you should be able to find a bunch of stuff on it if this video that you're watching doesn't make any sense. But yeah, let's just kind of jump right in. So this whole topic is on square roots, which are all of these symbols here. These are all square roots, and I'm going to talk more about that later. But it kind of relates to what we were talking about within factoring about perfect squares. All right. 4, 36, and 81 are all perfect squares. You guys should recognize those numbers by this point. And the reason why 4 specifically is a perfect square is because 4 is 2 times 2. All right. So I have the perfect squares half sheet that I gave you guys when we first started talking about perfect squares. So I think that's really going to help for this unit. If you have that, definitely have that out while you're doing this. If not, I might have already put in a second copy of it on Classroom, but if I haven't and you want one, let me know. So this is why we know that 4 is a perfect square, because 4 is 2 squared. So the square root is going the opposite direction. If 2 squared is 4, the square root of 4 is 2. Okay? Same thing with 36. We know 36 is a perfect square because it's 6 times 6. So the square root of 36 is 6. And 81 is 9 times 9. So the square root of 81 is 9. That's sort of how we have to start thinking when we talk about radicals. More specifically, simplifying radicals. So this is the topic I was talking about before. If you put this in a Google, like if you're not sure what you're doing, how to simplify radicals, that's where you're going to find all of this stuff. But basically, a radical is a square root. All right, kind of like we just did it in the warm-up. All right, there are things that are not square roots. There are cube roots, fourth roots, and fifth roots, but those things you deal with more in Algebra 2 in a couple years. Like it says here, we only really deal with square roots in Algebra 1. Flip the page. There we go. Okay. So, radicals are in their simplest form when the number under the radical, which is called the radicand, has no factors that are perfect squares. So here's what that means, all right? If you think about the factors of 33, what would they be? 1 and 33, and 3 and 11. And that's it, all right? And if you go back to your perfect squares list, none of those numbers are on the list, all right, as perfect squares. 33 has no perfect square factors, so the square root of 33 is fully simplified. But if you go to the factors of 18, what are the factors of 18? 1 and 18, 2 and 9, and 3 and 6. All right, obviously not all of them are perfect squares, but 9 is a perfect square. All right, so I'm actually going to set this up a little bit differently. If we want to simplify the square root of 18, we want to simplify it, or we want to break it up into factor pairs, kind of like these that we were doing in factoring, but we want one of those factors to be a perfect square. That's why I circled this 9. 18, or 9 is a factor of 18, and 9 times 2 is 18. So the square root of 18 can be broken down into the square root of 9 and the square root of 2. Because 18 can be broken down into 9 and 2. You know what I mean? And because we know 9 is a perfect square, we're able to actually evaluate the square root of 9 as 3. So the square root of 9 is 3, and because we don't know what the square root of 2 is, like if I actually took my calculator and plugged in the square root of 2, the square root of 2, it gets you this horrible decimal. All right. And we don't want to deal with horrible decimals. We just want to deal with nice numbers. So we're not going to deal with this horrible decimal, and we're just going to keep the square root of 2 as we see it. All right. So that, I know I just boxed it off a little bit prematurely, but that's your final answer for a question like this. So there is sort of a process. Oh, geez, blank piece of paper. There is a process for how we think about this, or something that makes sense to me. All right, if we're talking about the square root of 8, well, how do we know where we start? So we're going to look at this perfect squares list. Mine's double-sided. And we're going to figure out where 8 goes in this list. Like if we're looking at the right side of numbers, where would 8 fall? 8 would fall right here. I'm not going to write on it because I'm going to use this later or for the other problems. But 8 would go right here in between the 4 and the 9. So if I asked you for the biggest perfect square that's smaller than 8, that would be 4. Because 9 is bigger than 8. So if we tried to do 8 divided by 9, that wouldn't work. It would get us some fraction. So we're going to start out dividing 8 by 4 and go up the list until we get a number that's evenly divisible, or that 8 is evenly divisible by. Now we already know that 8 is divisible by 4. It's 2. So the square root of 8 can then be broken down into the square root of 4 and the square root of 2. Now, which one of these, again, is the perfect square? It's 4. We know the square root of 4. It's 2. We just saw earlier that the square root of 2 is going to get us a horrible decimal. So we're not going to deal with that horrible decimal, and we're going to leave it as the square root of 2. And because it's a product, right? When you think about factors of 8 are 4 and 2. So 4 times 2 is going to get you 8. So that's why we can kind of squish these together a little bit, and we can read this answer as 2 times the square root of 2. Or for short, 2 root 2 is how you would read something like this. All right, and that's example 1. Now, why I say to do that kind of process is because for bigger numbers like this, all right, if I go back to this list and I look at where would 48 fall in between all these numbers, 48 is going to fall in between 36 and 49. So what's the biggest perfect square that's smaller than 48? It's 36. So we're going to start with 48 divided by 36. See if that works. Oops. It doesn't. All right. We want a nice even or a whole number. So 36 doesn't work. So we're going to keep going smaller and smaller up the list until we find something that works. So we'll do 48 divided by 25. Doesn't work. 48 divided by 16. That's 3. All right. The whole goal here, I don't know if I mentioned this, but the goal here is to find the biggest perfect square factor of 48. All right. In this case, that's 16. So the biggest perfect square factor of 48 is 16. And we know 48, we just saw 48 divided by 16 is 3. So the square root of 48 can be broken up into the square root of 16 and the square root of 3. Now, why are we doing this? Because we know 16 is a perfect square, which means we can evaluate the square root of 16. What is that? It's 4. And the 3 isn't a perfect square, so the square root of 3 is also going to be a disgusting decimal. So we're going to leave it as the square root of 3. And that's our final answer. Now, here's the reason why I say biggest perfect square factor. All right? Because I'm sure some people are sitting there and they looked at 48 and they said, wait a second, 48 is divisible by 4. So I know 48 divided by 4 is 12. So I can also say 48, the square root of 48 breaks up into the square root of 4 and the square root of 12. Now I know the square root of 4 is 2. So wouldn't my answer be 2 root 12, Miss Waring? Are there 2 possibilities for a final answer for questions like these? No. All right. When we say simplify, you might have read this earlier. We're talking about fully simplified form. All right? So even though you are allowed to start like this, if this is what you notice, you would have to think about 12 as well. All right? We know 3 isn't a perfect square. We know 12 isn't a perfect square. But if I went back here and thought about factors of 3, it's just 1 and 3. Okay, 1 is a perfect square, but the square root of 1 is 1. Pulling out a 1 isn't going to change anything. What are some other factors of 12? We've got 1 and 12, we've got 2 and 6, and we've got 4 and 3. 12 could be broken down even further into 4 and 3, which means the square root of 12 is the square root of 4 and the square root of 3. And there's your perfect square of 4 that we worked with earlier. The square root of 4, again, is going to be 2. So the square root of 12 can simplify down even further into the 2 root 3. That's a 3. Now, what about this 2 from earlier? Well, we can't forget about it. And since this is a product, this is 2 times the square root of 12. We're doing 2 times the square root of 3. And what's 2 times 2? 4. So this is 4 root 3. And look at that. That's the exact same final answer that we got earlier. So that's why I suggest going from, like, this isn't a really good visual, but like the top down, all right? Going from the bigger numbers, doing the bigger numbers first, and then gradually getting smaller, all right? Because this is still correct work. It's just a little bit longer. Starting out with the bigger numbers and going with the bigger perfect square factors is going to get you your final answer a lot faster. And that's the way you're going to see me do it in all these videos, however many days we spend on this topic. All right? So for something like 200, I think, hopefully, if you have some number sense, you might have an idea on how 200 is already going to break down, but I want to go about it the long way. If we look at this list, where would 200 fall in this list of numbers on the right? It's going to fall right here, in between 196 and 225. So the biggest perfect square that's smaller than 196, that's smaller than 200 is 196. So we're going to start 200 divided by 196. Didn't think that was going to work. So we're going to keep going from 196 smaller until we get 200 divided by one of these numbers on the right-hand side gets us a whole number. So 200 divided by 169, 200 divided by 144, 200 divided by 121, 200 divided by 100. That's where I think most of you had thought originally. 200 divided by 100 is 2. So the square root of 200 breaks down into the square root of 100 and the square root of 2. And again, we're doing this because 100 is a perfect square. The square root of 100 is 10. And 2, there's no other factors of 2 besides 1 and 2. It's not a perfect square. So we're going to leave it as the square root of 2. So your final answer for a problem like this is 10 root 2. Okay? And pretty much the rest of these examples are just basically the exact same thing. So we're just going to do this whole process a million more times. Where does 180 fall on this list? It falls in between, where does it fall? 196 and 169. So the biggest perfect square that's smaller than 180 is 169. So 180 divided by 169 doesn't get us a whole number, so we'll just go up the list. 180, wow, 180 divided by 44. Now, there are certain numbers you don't have to check if you know that they're not going to work. Like, I know 180 isn't going to be divisible by 100. So I wouldn't plug that into my calculator because, I know that it's not going to work. If you don't know that's not going to work and you just want to keep going down the list until you get something, go for it. Like, I don't know if 180 is divisible by 81. It's not. Okay, there we go. 180 divided by 36 is 5. So 180, or the square root of 180, breaks down into 36, the square root of 36, and the square root of 5. 36 is a perfect square. Its square root is 6. And we leave root 5 alone. I usually put, like you'll also see me put the perfect square factors in front. Technically, the order doesn't matter, again, of the numbers. 5 times 36 is the same thing as 36 times 5. But I usually do this because this is what we're dividing by, and these are the numbers that you're taking the square root of. The square root sign is going to go away once you take the square root of 36. That's the other thing that a lot of people mess up on. Once you take the actual square root of 36, you don't need the radical sign anymore. It goes away. But because we didn't do anything with the square root of 5, that's why we're leaving it over the 5. Okay. I think 175 is going to go in exactly the same place. It's also in between 196 and 169, so that's where we're going to start. We're going to start with the smaller of the two, 169. So 175 divided by 169. And we're just going to keep chugging down the list until we get something. Okay. 175 divided by 25 is 7. So the square root of 175 breaks down into the square root of 25 and the square root of 7. The square root of 25 is 5. And 7 is not a perfect square. It doesn't have any other factors. It's a prime number. So your final answer is 5 root 7. Different area this time. 80 would fall in between 64 and 81. So the biggest perfect square that's smaller than 80 is 64. So we'll start there. And like I knew 80 wasn't going to be divisible by 25, but so like if you know these things, you don't need to go in and check them. But if you don't, you can just keep plugging and chugging. And there we go. 80 divided by 16 is 5. So the square root of 80 breaks down into the square root of 16 and the square root of 5. We know the square root of 16 is 4. And root 5 doesn't have, 5 isn't a perfect square. It doesn't have any other factors that we could think about. So we're just going to leave it as the square root of 5. And I believe this next one is the last one. 98 falls in between 81 and 100. So the biggest perfect square that's smaller than 98 is 81. Okay, 49. The square root of 98 breaks down into the square root of 49 and the square root of 2. 49 is our perfect square. It's 7 and 7, so the square root of 49 is 7. And we've seen the square root of 2 a million times by this point. It's not going to get us anything. Can't simplify it. 2 isn't a perfect square. So we're going to leave it as the square root of 2. And that's your final answer, 7 root 2. Or 7 times the square root of 2. All right? So, again, definitely feel free to use Hangouts to ask questions. The question forum, which people haven't really been using. Maybe I'll try to do another meet session at some point before the week wraps up. And as usual, I hope you guys are doing okay out there. Talk to you soon.